Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
How are you, everybody who is watching this program? I would like to take this opportunity to welcome all the national and international students into our online schools that called TANZANIA Online Advanced Secondary School in square bracket Olenjolaim. My name is Olenjolaim, Mokota Yellow Single. Simply just you can call me Olenjolai. I thank God by His own grace. He has given me a gift of teaching advanced secondary students and even some other levels of studies. I would like to take this opportunity to welcome you and ask you to be serious and join me in the next session. Right now, let me take this opportunity to welcome you into one of our online schools that called TANZANIA Online Advanced Secondary School in square bracket Olenjolaim. And this is our official YouTube channel that called TANZANIA Online A-Level Secondary School in square bracket Olenjolaim. We have more than 3 departments. One of the departments is called Advanced Chemistry. In Advanced Chemistry, we are teaching 2 subjects, Advanced Chemistry for the Form 5 and Advanced Chemistry for the Form 6. And today we are going to cover about the main topic 3, which is called Advanced Organic Chemistry. And this is specifically dedicated to the pre-Form 5 students, Form 5 students, preceptors, QT students, grade 12 students, teachers, and physicists. And in your main topic of advanced organic chemistry, we have so many top chapters or topics. And this is the second topic that called saturated and unsaturated hydrocarbons. My dear students, I'd like to invite you in session 19, which is titled as Laboratory Preparations of Alkenes. So again, in case that you want to interact with me online, if you're an online student, it's your first time, remember to register yourself and follow the steps ahead. And if you are not a first time student, you're warmly welcome, but you can interact with me by using the comment sections of this video below, where you can ask me questions, where you can submit your homework, where you can give us feedback about your understanding concerning about our program. Again, maybe you can ask yourself a questions, what are we doing in this program? Well, so we are here in order to teach and train students on how they can extract knowledge, understanding, and wisdom from the classroom instructions and combine it with knowledge, understanding, and wisdom that we are going to teach them to extract it from the Word of God in order to solve real life problems. So the main objective of TOASO is not to teach students to pass Advanced Certificate Secondary Education Examination. It's not to teach you to pass your continuous assessment. It's not to teach you in order maybe to master Advanced Chemistry or Advanced Physics. No. The main objective of TOASO is to teach our students to think differently and think on how they can solve real life problems. I know what I'm telling you, it may be sounding difficult, but I want to tell you that myself, as your teacher, I'm an example of what I'm telling you. I've been combining knowledge and wisdom from maybe from the classroom instructions that I've been learning in different fields, for example in science or in mathematics or in engineering, and the knowledge that I've been learning from the Word of God and apply to solve real life problems. And I want to tell you that I used to be successful, rather than if I use maybe a knowledge from the classroom instruction itself, because sometimes it can be lacking something else in order to make sure that they succeed on what I'm doing. So I'll be teaching you the different techniques and different styles. However, that in these programs you might be finding that the videos we are publishing in our online school will be teaching you about classroom instructions, rather than how you can combine the classroom instructions with the wisdom from the Word of God. But why are we doing that? Because I know many students are stressed with the classroom instruction first. They have a fear of the national exams ahead of them. They have a fear of mock exams ahead of them. So the only alternative is to reduce your stress first. And then from there, if you are free from stress, then now I can teach you how to think outside of the box. Because according to the Tanzania educational system, many students in advanced level, they are focusing on passing the final exam, while the objective of advanced secondary education is not to push students to focus on the final exams, but the main objective is to teach the advanced secondary students to solve real-life problems. So you can find that the students, instead of solving the real-life problems that exist in the year community, they'll be focusing on preparing themselves for the OT, for the final exam. But that is our educational system. And actual, if you think differently, you might find what we are doing and what we are pushing students to do is kindly wrong. Because students, they can pass all the exams, but to pass all the exams, it doesn't mean that you'll be successful in life. If you want to be successful in life, is in case you see opportunity or in case you see a problem and you solve it. That's how. That's all. So I don't want to say that I disobey your rule or your focus. That's why I say that I will help you in that aspect, because helping you to pass your next exams or your final exams is one of our specific objective, but it's not our main objective. So our main objective to see our students solving real life problems, regardless that you'll spend 3 years or 4 years or 5 years or 10 years. That's what we want to tell you. It's very important for you to take a focus on it. All right? So if that's the case, let us go into our today's session. So we'll be focusing on laboratory preparations of alkenes. So we say that, if you do remember, that we have something called the hydrocarbons. So let me just do the quick review of previous session. Okay? So we say that we have something in chemistry called the hydrocarbon. And these hydrocarbons, we can categorize them into 2 branches. And these 2 branches, the first one is called the alkenes. And this one on this side, no, excuse me, this is called the saturated hydrocarbons, and on this side we have unsaturated hydrocarbons. On saturated hydrocarbons we have alkane. In the context of alkane, I have taught you the real concept, if you do remember. The first one, we used to teach you about nomenclature of I think that 4 concepts, if just you want to go. Okay, the first one, let us say nomenclature, the meanings of alkane and whatever, but the main focus will be nomenclature, laboratory preparation of alkane, and also chemical reaction. We used to discuss about physical properties, but chemical reactions is very important. So in unsaturated hydrocarbons, also we have 2. We have alkane. So we have, because when we say unsaturated hydrocarbons, we have aliphatic, and also we have aromatic hydrocarbons. Unsaturated hydrocarbons, we have aliphatic and aromatic hydrocarbons. So in aliphatic hydrocarbons, here we have what? Alkenes, which we are going to learn today, and also we have what? Alkynes. So in alkenes, also we cover about nomenclature, we cover about laboratory preparations and chemical reactions. Okay? So today, our session 19 is focused on laboratory preparations of what? Of alkenes. So let us focus on laboratory preparations of alkenes. So we say that Alkenes, so we are starting our today's session. Alkenes are prepared in laboratory by using or by what? By elimination chemical reaction. By elimination chemical reaction. By elimination chemical reaction. By elimination chemical reaction. So alkenes are prepared in laboratory or in chemistry laboratory by elimination chemical reaction. So the following are the 3 methods that are used to prepare alkenes in laboratory. The first one is called the dehydrohalogenations of alkyl halide. Say with me, dehydrohalogenations of alkyl halide. Hey, dehydrohalogenation. Are you sick? Pardon?
Dehydrohalogenation.
Again.
Dehydrohalogenation.
So one student is speaking. So others they are sleeping. Dehydrohalogenations of alkyl halide. The second one is called the dehydration of alcohol. Dehydrations of alcohol. And the third one is heating of vicinal compound. Heating of vicinal compound by what? By zinc. Heating of vicinal compound by zinc. So the first one is called the dehydrohalogenations of alkyl halide. The second method is called the dehydrations of alcohol. The third method is called the heating of vicinal compound by zinc. Heating of vicinal compound by zinc. This elimination reaction by those 3 methods are carried out by following a rule we call the Seit-Zef. So how does it state? Seit-Zef's rule. Seit-Zef rules state that, very important, because this rule is it's ruling or it's guiding all the three methods of preparing alkanes. So safe rules state that during elimination reaction, state that during elimination reaction, the hydrogen is eliminated from the carbon with few number of carbon atoms. The hydrogen is eliminated from, okay, this is the rule, so I just underline, may not underline, it's okay. So reaction state that during elimination reaction, the hydrogen is eliminated from the carbon with few number of hydrogen atom. I don't know if you have met with this rule, but if you have never met with it, then you have to experience it from today. So during elimination reaction, the hydrogen is eliminated from the carbon with few number of hydrogen atoms. During elimination reaction, where do we get this elimination reaction? Preparations of what? Of alkanes, right?
Yes.
The hydrogen is eliminated from the carbon with few number of hydrogen atoms. Why does this rule state? It means that we can find an organic compound that undergoing elimination reaction, and then the carbon with few number of hydrogen atoms, and the carbons with large number of hydrogen atoms. So the hydrogen atom will be eliminated from the carbon with few number of hydrogen atoms, right? But again, sometimes you can find an organic compound, and the part which undergoing elimination reaction, and as you want to do elimination, you want to eliminate, because eliminations you are removing something. And in most cases, it means that we say in elimination you are eliminating hydrogen atom. So there's an equal number of hydrogen atoms. So it means that each carbons, either of the carbons, may eliminate or may allow its hydrogens to be eliminated, because you have only two possibilities: to have an equal number of hydrogen atom or to have equal number of hydrogen atoms. Okay? And whenever you hear something about eliminations, in most cases, that if we eliminate something, we can find or we can formulate something we used to call it in chemical bonding, the pi bond in most cases. If you eliminate something, it means that you are breaking the bonds, then you can form a new bonds between the identical atoms or non-identical atoms. Are we together?
Yeah.
So this is what Sator's rule that we are going to apply when we're learning all the three methods. Okay, so if that's the case, because we know the rule now, we can go to the first method. And the first method is called the dehydrohalogenation. Dehydrohalogenation of what? Of alkyl halide. Dehydrohalogenations of alkyl halide. I believe that you love organic chemistry of alkyl halides. dehydrohalogenations of 40 of alkyl halides. So let me put alkyl halides in plural. And you know the functional group of alkyl halide is Rx. So dehydrohalogenations of alkyl halide. So the fundamental question of OLENJOLAI, first of all, before we move on or we go further, let us define first what the means of dehydrohalogenation. What is dehydrohalogenation? We defined dehydrogenation. We didn't find dehydrohalogenation. So we define dehydrogenation, and this is dehydrohalogenation. So what the means of dehydrohalogenation? As was dehydrogenation. So in Alkane we define dehydrogenation. Here you have dehydrohalogenation. So dehydrohalogenations means here too. Dehydro means always is removing, but this way hydro presenting hydrogen. Halogenation presenting what? Group 7 element means halogens. So here it means we are removing 2 atoms. And let us see the definition first, and then we'll see how does it work. Dehydrohalogenations is an elimination reaction which removes. So dehydrohalogenation is a elimination reaction. Is an elimination reaction which removes hydrogen and the chlorine from what? From alkyl halides. From alkyl halide to form what? To form either alkenes or alkynes. So dehydrohalogenation is an elimination reaction which removes hydrogen and chlorine from alkyl halide to form alkene or alkynes. And the definitions of what is dehydrohalogenation. So that's the definition. So then let us discuss about the method of preparing alkenes. So say the hydrogenations of alkyl halides so we say alkenes can be prepared in laboratory. They can be prepared in laboratory by dehydrogenation dehydrohalogenation of what? Dehydrogenations of dehydrogenations of alkyl halide when alkyl halide is treated by alcoholic potassium hydroxide or sodium hydroxide. So the reactions can take place when alkyl halide is treated or is reacted with potassium, alcoholic potassium hydroxide or alcoholic sodium hydroxide. So from there, we get what the dehydrogenation. So the general word equation, chemical equation, general word chemical equation. General word chemical equation. We say that we have alkyl halide. This is, we have alcoholic potassium hydroxide. And here we have alcoholic sodium hydroxide. So then the product is what? Is alkene. Is alkene. Alcoholic potassium hydroxide or alcoholic sodium hydroxide. And here we form alkenes. So overall reaction, here we have alkyl halide, CH2, CH2X, for example, and this one we treat it under alcoholic potassium hydroxide or sodium hydroxide. Then this one form alkyl group. Then I have double bond, hydrogen, no, hydrogen, then plus hydrogen halide. So this is general word chemical equation. This is overall molecular or just overall or general also chemical equation. So I think that the best way I have to make sure that I do it is because always used to focus on the general form. So, for example, our reactant, we have maybe a certain hydrocarbons, and these certain hydrocarbons, so you say that we have here carbon, hydrogen, we have here, let's say, chlorine, and this is hydrogen. So students, listen, this is what we call the alkyl halide. So this is hydrocarbons, and X stands for halogen. Right? Remember that. X stands for what? For halogen. So always X stands for halogen. Remember that. X stands for halogen. Halogen means group 7 and so examples of halogens are what? Fluorine, chlorine, bromine, iron. So you can write down. X represents what? Halogen. Examples of halogens are, I'm talking to you, Patrice. X represents halogens. Examples of halogens are fluorine, chlorine, bromine, iodine. So write it down and keep it in your mind because we mention it often. So this is an example. This is a hydrocarbons. R represents hydrocarbons, means that it's an organic, it's a fatty compound which contains carbon and hydrogen, right?
Yes.
So suppose that this is a certain alkyl halide. It can be maybe chlorethane or chloropropane or chlorobutane or chloropentane or chlorhexane or chloroheptane or chloroctane or chlorononane, chlorodecane. It can be. So it means that this is a general form. Okay? So you are doing in general form because when we will be given a questions of chloropropane, so you can follow the following steps. So say that the example complete the reaction below with mechanism. And these reactions is we have alkyl halide here. We have our alkyl halide like this, the chlorine, then we treat it with what? With alcoholic. For example, alcoholic potassium hydroxide, what will be the product of the question. So this will give us the overview about elimination reaction. So we have our friend here. So stop writing, listen, follow along. So here you have hydrogen, here you have carbon, here you have hydrogen, here you have hydrogen, here you have chlorine. Listen. And then we are treating it under presence of what? Potassium alcoholic, potassium hydroxide, or sodium hydroxide. First of all, do we have Cites rule there? For the how many carbons do we have which show the number of hydrogen? Huh? 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 Listen carefully. So we have 2 carbons which show the number of hydrogens. How many, for the first for this carbon, how many hydrogen atoms does it contain? 2. Eh? 2. And for this one, how many number of hydrogens does it contain? 2. But in order to form alkyl halide, you know that this chlorine has displaced your hydrogen atom. You agree with me?
Yes.
Yeah. So if it was alkane, means this was the positions of what? Of hydrogen atom. So between this carbon and this carbon, for that case, if here we had a hydrogen, between this carbon and this carbon, which has a least number of carbon, which has a few number of carbons. Eh? Let me repeat my question. At this moment, these 2 carbons have the same number of hydrogen, right? But this chlorine has displaced 1 hydrogen there. Okay?
Yes.
So if this chlorine, if the hydrogens attached in these carbons is not displaced by chlorine, which carbon has a fewer number of hydrogen? The middle one, this one, is it?
Yes.
So according to Cites rules, how does it state? State Cites rules. You are reading. It's not in your mind. State it from your mind. You see answers are scanning there. During elimination reaction. Then during elimination reaction. Keep it in your mind. During elimination reaction, the hydrogen is eliminated.
The carbon with a few numbers of hydrogen atoms.
It's a few number of hydrogen atoms. So if these compounds will undergo elimination reactions, where do you expect the hydrogens to be eliminated?
In the middle.
Huh?
The middle carbon.
From, suppose this is the first carbon, this is the second one. If, according to the Saitius rules, we say that if a compounds undergo elimination reaction, the hydrogens eliminated from the carbons with few number of hydrogen atoms. So, between the first carbon and second carbon, which carbon has a few number of hydrogen atoms? The first. So the hydrogen will be eliminated from this carbon or this carbon? The first carbon, right? Okay, good. So you have to listen. So if that's the case, between chlorine and between carbon and chlorine, which is more electronegative? Chlorine, right?
Yes.
So remember that in elimination reactions we break bonds, and not in every organic reactions we break bonds and form bonds. So chlorine is more electronegative more than carbon. So this bond will be breaking in this way. So chlorine will become a nucleophile while carbons become electrophile. Okay?
Yes.
Why? This is more electronegative. First of all, the bond between carbon and chlorine, is it electrovalent or covalent? The bond between carbon and chlorine, is it electrovalent bond or covalent bond? We taught you electrovalent bond and covalent bond in chemistry of O level. Is this electrovalent bond or covalent bond? Huh? Huh? Covalent bond. So it's covalent bond. So covalent bond, is it formed by transfer of electrons or sharing of electrons? Sharing of electrons. So chlorine, it means donate, it means it shades electrons, and carbon it shades electrons. So if this bond break, so it means we said what? So we say that this is covalent bond, right? Sharing of electrons. So when we say this bond breaking this way, it means chlorine is going to withdraw all the bonding electrons. Because at this time, chlorine donated 1 electron, carbon donated 1 electron. So when bond break heterolytically, because we have homolytic cleavage and heterolytic cleavage, it means chlorine is going to withdraw all the bonding electrons. So when the bond will break now, chlorine is rich. It has 17 electrons of itself and 1 additional electrons from from carbon. That's why carbon is partially positive, because carbon has lost 1 electron. Are we together?
Yep.
So now the product there will be R, which represents hydrocarbons, carbon, hydrogen, here you have hydrogen, here you have carbon, here you have hydrogen, here you have hydrogen, and this is partially positive, plus what? Chlorine as partially negative. Then we still have the same condition, which is alcoholic potassium hydroxide. Are we together?
Yes.
Then, remember that we cannot formulate the same bond which we broke it. So we always break the bond and form the new bond. Then we come to this part. Now we come into the Saitius rule. So we want to remove or to eliminate 1 hydrogen here from the carbons with fewer number of hydrogens. Stop writing, I say. Stop writing. We say that according to Saitius rules, during elimination reaction, the hydrogen atoms is eliminated from the carbons with few number of hydrogen. Right? So here we are. So you want to remove an hydrogen. So to remove an hydrogen, you have to break the covalent bond. Right?
Yeah.
Between hydrogens and carbons, what type of the bond? Is it electrovalent or covalent? Covalent. So covalent is what? Sharing of what? Electrons. So now, between carbon and hydrogen, which is more electronegative?
Carbon.
Huh?
Carbon.
Carbon is more electronegative. So if it's more electronegative, when the bond break, carbons will withdraw all the electrons and hydrogen will lose its electron. So carbon will become partially negative and this side will become partially positive. Patrice, are you there?
Yes.
So listen carefully. Say stop writing. So here we have our hydrocarbons, here we have carbon, here we have hydrogen, and this here in this carbon we have what? Partially what? Negative.
Negative.
Right?
Yes.
Then you have a bond with this carbon, And then you have a bond with hydrogen there. We have a bond with hydrogen there. But also this hydrogen says, this carbon says lost one electron. That's partially positive, right?
Yeah.
Plus what? So here we had what? Chlorine, which is partially negative, plus what? We have hydrogen, which is partially positive. And then the conditions, we are still treating it in alcoholic potassium hydroxide. Are we together?
Yeah.
Are we together?
Yes.
Here we have partially negative carbon and partially positive carbon. Or simply say that we have a carbon which is rich with electron and a carbon which is deficient with electron. Right? So whenever we have partially negative and partially positive, here we can form a new bond which we call it pi bond.
Yes.
Right?
Yes.
Right? Pi bond is in most cases, okay. So the pi bond and the pi bond, this will be formed between a carbon or between an atom which is partially positive and partially negative. Right?
Yes.
So here the new bond will be formed. So we say that we have R, and then so we have what? We have carbon, we have H, and then so we say what? So we have another carbon, we have a sigma. This is called sigma bond. This is sigma bond, this is sigma bond, right?
Yeah.
So now we are forming a new what? A new bond. Partially negative and partially positive. What does it mean? It means this partially negative is donating electrons to the partially positive carbon. Right? And then here we have what? We have hydrogen plus. So we don't write this partial negative, partial negative, partial positive any further more because we formed a negative bond. We formed a pi bond, right?
Yeah.
Then plus what? So here we have what? This is rich with electrons, this is poor with electrons. So what is going to happen? This one is going to donate electrons to hydrogen. Right? And then forming what? Hydrogen chloride.
All right.
Are we together?
Yes.
So right now we have what? R. Then we have carbon. We have double bond with this. Okay. Here we have one hydrogen. And here we have what? An hydrogen. An hydrogen atom. Plus what? Hydrogen chloride. So what we have produced here, you see, is what we have. So our X is chlorine, hydrogen chloride. And then we have double bonds between carbon and carbon. And here is double bond between carbon and carbon. Are we together?
Yeah.
There is no need for you to claim. Why? Because just you have to know the principles and then breaking the bonds and forming the bonds at all. So you see the elimination reactions, how does it form what? Alkene. Because this is an alkene right now. So if that's the case, so let's say that this is example 1 for this case. So for the students who didn't understand, let me do like example 2. Complete the following elimination. Elimination reaction with mechanism. If you'll be given this question and you are not asked to do them, maybe to show the mechanism, then you show the mechanisms or you do the mechanisms on the rough paper, but in your booklet, you just write the reactions which have been asked. So these mechanisms is just a trick we are teaching students on to understand how the organic reactions take place. Sometimes some of the teachers or some of the examiners, they don't prefer you to show just the mechanism of table. So this is for your advantage. Rather than guessing that maybe, no. Thus you have so many reactions in your mind, so you're confused. Okay?
Yes.
So CH3, CH2, OCH. So this one react with alcoholic potassium hydroxide or sodium hydroxide. So it's simple. Solution. So just you have to follow the step that I told you. So carbon, you have hydrogen. This is cyclopropane. Say cyclopropane. So cyclopropane. And here we have a bond with chlorine. And then we say that the conditions of, yes, the conditions is alcoholic potassium hydroxide, for instance. So I told you. So for this level, because now you understand the bond break this way, right?
Yes.
Partially negative, partially positive. So you have CH3, you have carbon, you have hydrogen, and here you have bond with this. And here you have what? Carbon, you have hydrogen, you have partially positive, you have chlorine, which is partially negative, under the presence of what? Alcoholic potassium hydroxide. So the bond again break here. This carbon become electronegative. This is partially positive. This is partially negative. So CH3, then you have CH, we are going from double bond here, and then you have two hydrogen, and these hydrogens will form hydrogen chloride with chlorine. Okay? That's the final product. But here we have what?
Yes.
We have cyclopropane. So there is no need for you to crave. So you can write now the overall reaction. The overall reaction, you have CH3, CH, alcoholic potassium hydroxide, so even something you can just write, this is CH and this is CH2 plus hydrogen chloride. That is called the dehydrohalogenation reaction. So homework 19, which is example 3, complete the reaction below this mechanism. If you are joining me right now, welcome into this fantastic session 19 of laboratory preparations of alkenes as unsaturated hydrocarbons. We are here to help you to learn, understand, and even to apply what we are teaching you in solving real-life problems. Okay, so that's all. If you have any question about the first method of preparing alkanes, now is the right time for you to ask it before I go into the second method of laboratory preparation supporting of alkanes. The first method is called the hydrohalogenation of alkyl halides. The conditions is alcoholic potassium hydroxide or alcoholic sodium hydroxide. So if there is any question for the online students, you're warmly welcome. If there is any question for physical students, you're warmly welcome before we dive into the second method of preparing alkenes. Is there any question? Silence means well taught and well understood. But you have to be careful because it might be well taught, well understood, and well forgotten. Okay? You might be well taught, you have understood it well, but you can forget it well. So you are expert in every aspect of learning. So the second method is called the dehydration. Dehydrations of alcohol. Dehydration of alcohol. That's the second method of laboratory preparation supporting of alkenes. Then the fundamental question for Olenjolaim whenever he teaches you a new vocabulary, because this is the new vocabulary I've never mentioned about dehydration. I've talked about the hydrolysis. Hydrolysis is not dehydration. Dehydration is something else. So this is the fundamental question for me whenever I introduce to you a new terminology. I want you to understand it before you apply. What is dehydration? Here, I want to teach about dehydration of alcohol, but what does the word dehydration means in organic chemistry? What does it mean? Whenever you hear the word dehydration as a chemist or as a student who loves chemistry, what do you understand? So what is dehydration reaction? What is dehydration reaction? So my dear student, in chemistry, our favorite subject, in chemistry, the dehydration reaction. The dehydration reaction is a chemical reaction. So the dehydration reaction is a chemical reaction that involves, this is the chemical reaction that involves the loss of water. That involves the loss of water. The loss of water, which means that two hydrogen atoms and one oxygen atom. From organic compound, loss of water from organic compound to form alkenes and what? From alkenes and what? From alkenes or alkynes. From alkenes and the water. So dehydration reaction is a chemical reaction that involves what? Loss of water or loss of 2 hydrogen atoms and 1 oxygen atom from organic compound. From organic compound to form alkenes or alkynes and water. Right? So when you talk dehydrations in the context of the dehydrations of alcohols, so it means that dehydrations of alcohols is a chemical reaction that involves the loss of water from alcohol to form alkenes or alkynes and water. At the means of what it's quite different from hydrolysis. You have to be careful when you're learning organic chemistry, because you might find that some of the reactions are similar. No. So for that case, you say that dehydration of alcohol, say that is a chemical reaction that involves the loss of water from what? From alcohol to form what? Form alkene or alkyne. And what? And water. So later on, when we'll be learning about alcohol, and especially the chemical reactions of alcohol, one of the chemical reactions will be this one, that alcohol can undergo dehydration to form alkenes. So you see, that's why I tell you that means that each subtopic of organic chemistry depending on another subtopic. So most of the concepts in organic chemistry, they depend on each other. So dehydration of alcohol, dehydrations of alcohol take place under the presence of what? Of excess sulfuric acid. And the excess of sulfuric acid and the temperature ranges in between of what? 160 degree to 180 degree. So we should have excess concentrated? Yes, excess concentrated sulfuric acid. Excess concentrated sulfuric acid and temperature ranges in between 160 degrees centigrade and 180 degrees centigrade. So the hydrations of alcohol takes place under the presence of excess concentrated sulfuric acid and temperature ranges in between of 160 degrees and 180 degrees centigrade. Other dehydrating agents are aluminium oxide or phosphoric acid. Aluminium oxide or phosphoric acid. Aluminium oxide or phosphoric acid. So as hydrating agents are aluminium oxide or phosphoric acid can be used in this dehydration reaction of alcohol. Okay, so you say that general wet chemical reaction. General wet chemical reaction. So here you have what? We have alcohol, then condition is what? Say excess conco sulfuric acid and the temperature of 170 degrees centigrade. This will form what? Alkene. Plus what? Plus water. It's the big picture. So when alcohol is treated by excess sulfuric acid and the temperature of 170 degrees, then the product will be alkene and water. Again, this is the preparations of what? Preparations of laboratory. This also laboratory preparations of what? Of alkynes, because in alkynes just we have the iterations of diol. So we won't spend much time because everything will be well simplified or well taught, or well covered in the previous session. So we say that, okay, what the functional group of alcohol, this is the functional group of alcohol, let's say R, CH2, OH. Then we treat alcohol under presence of what? Excess conco sulfuric acid, and the temperature is 170 degrees. This one form what? This is forming product of CrCH, then CH2 plus water. So the question is how this dehydration or how dehydration reactions take place. So this will make example 4 of this session complete with mechanism elimination, dehydration, reaction below. So you have R, CH2, CH2, hydroxide, excess sulfuric acid, and the temperature of 170 degrees. So the mechanism, so say solution, we have alkyl compound or hydrocarbons. We have the bond with this hydrogen. And we have hydroxide. So we have excess concentrated sulfuric acid and a temperature of 170 degrees. So we have to think about breaking the bond. So separating, it's time now to think logically and chemically. So separating, I said, we have 2 carbons there, which are adjacent carbon, we call them. And you have a bond between carbon and the oxygen. Is it a covalent bond or electrovalent bond? Covalent bond. So between carbon and oxygen, which is more electronegative? Oxygen. So oxygen will be drawing all the bonding electrons and make it to be partially negative and carbon partially positive. Right?
Yes.
So if that's the case, then we have what? R, carbon, hydrogen, hydrogen. And you have carbon, you have hydrogen, you have hydrogen. But this carbon is partially what? Partially positive. It is deficient with electrons. Plus what? Plus hydroxide. It's partial negative. And then we have what? Still have excess what? Concord sulfuric acid. So at this point, we have this is partially positive. Then we have a covalent bond between hydrogen and carbon. Okay?
Yes.
So when you have a covalent bond between hydrogen and carbon, which is more electronegative between carbon and hydrogen. Yeah? Carbon. So when the bond break, then carbon is going to store all the bonding electron. So this one be partially negative and this one be partially positive. Okay?
Yes.
So for that case, we have R, we have carbon, and this carbon is hydrogen. This is partial negative. Here we have carbon, this one hydrogen, partially positive, plus what? Hydrogen partially positive, and then plus what? Plus hydroxide partially negative. Okay,
Yes.
are we together? So the condition is under excess what? Saturated sulfuric acid (170°C). So if that's the case, here we are forming what? A pi bond, while this one also is donating its electrons to form water. So we have hydrocarbon, then we have carbon, we have double is carbon, we have hydrogen, plus what? Plus water. Right? So for raw reaction, we say that we have R, CH2OH under excess concord sulfuric acid. This will form what? RCH2 plus what? Francis, are you there? Sure? No, it seems like you're not there. Where are you? Huh? Are you in this house? Huh? Are you in this house physically or mentally? You're not here? Or? Very sure. Or you're giving us just motivation, current that you're together. Okay, homework. 19. This is the example 14. Example 8. Example 5. Complete. Following chemical reaction with mechanism. So you can try to answer those few questions that will test your understanding in the hydration of water. The hydration of the hydration of alcohol. And the said method or said laboratory preparations, the said method of preparing alkenes in laboratory is called the halogenation of vicinal compound. This is not long because it is straightforward. The halogenations of vicinal compound. The halogenations of vicinal compound. The vicinal compound is an organic compound which it is a particular structure. Okay, so I have taught you the hydrohalogenation, not the hydrohalogenation, and now we have dehalogenation. Those are the three different terms. Dehydrogenation, dehydrohalogenation, and dehalogenation. Do you feel them, man? They seem like the same, man. So this is another new reaction. So as my custom or my tradition, I have to teach you first the meaning of the terminology. What is the hydro? What is the halo? What is the halogenation? What is the halogenation? The halogenation reaction. Before we deal with vicinal compound, what is the halogenation reaction? The halogenation reaction. So you say that the halogenation reaction we defined as is a chemical reaction So the halogenation reaction is a chemical reaction. Is a elimination for say chemical reaction. Is a elimination chemical reaction. This is the elimination chemical reaction in which two halogen atoms are eliminated from vicinal compound to form form alkenes. Form alkene. So the halogenation reaction is the elimination reaction, is the elimination chemical reaction in which two halogens, so here we have two halogens that are two halogen atoms are eliminated or are removed from what vicinal compound to form what alkenes. So the next vocabulary is vicinal compound. What it means for vicinal compound? Because now you know the halogenation. Do you know about vicinal compound, or you just want to claim it? Because I know students, they say that, sir, we can claim it. Don't worry about that. So what is vicinal compound? So after defining vicinal compound, then now we can see the overall chemical reactions of what? Of the halogenations of vicinal compound. Because you know the halogenations, what the means of the halogenation, and also you know what the means of vicinal compound. Rather than claiming the reaction itself, don't know what the means of the halogenation, don't know what the means of vicinal compound, then we'll be claiming. So you say, in chemistry, you say that vicinal compound you say that. So vicinal compound is the compound which has two halogen atoms. So that's two halogen atoms. So vicinal compound is a compound which has two halogen atoms attached at or attached between two adjacent atoms, which has two identical. These halogen atoms should be identical. Then they try to find chlorine and bromine, which has two identical. I'm about to finish this session. I want students to be happy. Has two identical halogen atoms. Which has two identical halogen atoms attached at two adjacent carbon atoms. That's what we call vicinal compound. So vicinal compound is a compound which has two identical halogen atoms attached at two adjacent carbon atoms. So example of vicinal compound before we take it into reaction is this one. That if you have CH2 chlorine and then CH2 chlorine, this is the vicinal compound. Okay? Which you call the 1,2 dichloroethane. And then you can have another one, CH3, CH, and here we have bromine, and here we have CH2, here we have bromine. This is the example of vicinal compound, which you call the 1,2 dibromopropane. Okay?
Yes.
Then we can have maybe CH3, then here we have what? Maybe this one cyclo compound, have CH, then you have CH, and then here we have what? Bromine, and then CH, H2, bromine. So that is 1,2 bromo. Then hyphen what? 3 cyclopropane. Then what? Butane.
Yes.
Okay?
Yes.
So this is attached group, attached group, attached group. So the point there is just to see these two identical halogens atoms attached at two adjacent atoms. So these are adjacent atoms, adjacent atoms, adjacent atoms. Okay?
Yeah.
So those are the examples of what of bisphenol compound. Maybe if you want to number them, first example is this, second example is this is the third example. Okay.
Yeah.
So you say again another key when you say this, no? No compound can be the halo, they are halogenated into what? To alkenes. So can be halogenated into form alkene. When it is heated, when it is heated with zinc dust, when it is heated with zinc, when it is heated with zinc or zinc dust. So the general red chemical reaction, it is, here you have what, a vicinal compound, react with zinc dust, under what condition? Under conditions of heat. It means we say we heat this vicinal compound. Then the product will be alkene plus zinc chloride. No, plus zinc halide. So it's made that vicinal compound. This is hydrocarbon carbon with X. Remember X representing what? X representing what, students? Halogens. So here we have a vicinal compounds, which is halogen. Then we add up with zinc. Then the conditions is heat. Condition is heat. Then now, this is hydrocarbon. We have carbon. We have carbon. We have hydrogen. We have hydrogen. And here we have hydrogen. Plus what? Zinc. X. Subscript of 2. Okay?
Yes.
So in this one, there's no need for you to do a mechanism, but I want to show you what is happening. Complete the chemical reaction below. So this chemical reaction we have what? We have CH3, CH2, chlorine, plus what? Zinc, and the presence of heat. So listen. There's no need for you to focus on mechanism, but the only thing is when this reaction takes place, this chlorine is removed and this chlorine is removed. One will be mean that then we have the formations of what? Double bond.
Yes.
Between these adjacent carbons. Right?
Yeah.
And these two chlorine will react with zinc because zinc when ionize, it loses 2 electrons. Right?
Yes.
And chlorine when it ionizes, it needs 1 electron and this one needs 1 electron. So because you have 2 chlorine atoms, they can receive 2 electrons from what? From zinc. Then you have a product. Right?
Yes.
So for example, for this side, we have what? CH3, CH2, then you have double bond with this. You have hydrogen there, you have hydrogen there, you have hydrogen. That's what? Zinc, chloride. Okay.
Yeah.
Okay.
Yes.
Simply, this chlorine and this chlorine are going out, we form a double bond here. So this chlorine, so it means 1 chlorine has been removed here, has been eliminated, and 1 chlorine has been eliminated, then we form what? A double bond there. That's all. Okay? Are we together?
Yes.
Yeah. So because if, for example, we consider about the mechanisms, it can challenge you a little bit because this is more electronegative more than this. This is more electronegative more than this. So if you break the bonds, you can find that these are kind of electrophile, which is not true. Unless maybe you consider these are the free radical. So when they break heterolytically, chlorine leaves its electrons, this one is electrons. This is electrons, this one leaves its electrons. So it means that the bond breakings or the bond breaking for this case, it's what? Free radical. Okay, this one form a free radical, this one form a free radical. Then this one and this one free radical. So free radical and free radical can react. Okay, yes. But you should not complicate life like that. The simple thing is for any vicinal compounds reactions or for any laboratory preparations by the halogenations of vicinal compound, these 2 chlorine atoms will be removed and form what? The alkenes, that's all. Okay, are we together?
Yes, sir.
Okay, so if you've understood, So you can try that. Try to complete this. Okay, so when you are trying to complete that once, you can pause the video and then trying and doing that. If you understand this stuff, they are not too much complicated. They are not easy. They're neither easy nor complicated the way you think. And this is the end of session 19. So I'll like to invite you into session 20. But you can ask questions about session 19 in comment sections of this session. And also you can give me your recommendations and your feedback if you've understood or maybe didn't understand about the ordinations or whatever or something else, or a particular mechanism still have some kind of doubt. And sometimes you can find, for example, these kinds of reactions, maybe the sulfuric acid may be involved in mechanisms, that's all. So there are different ways that we can navigate with this stuff. So what did I write here? Did you write O or OH? OH. Have you written OH?
Yes.
Sure.
Yeah.
Check it. You have written oxygen. I know that you're excellent in copy and paste. Check. Because tomorrow you come back and say, sir, yesterday you wrote oxygen. You didn't teach us about oxygen. You taught us about hydroxide. So you failed because you gave us something else differently from what you have taught us. So make sure that you ask the questions, make sure that you watch the video several times as well as you can, and make sure that you think about these concepts, enjoy them, and you have a connections of this stuff of organic chemistry from the beginnings to this point. And you have to get prepared because session 20 will be, I'll be teaching you a little bit about physical properties, just within maybe 5 minutes or 10 minutes. And then the rest of the session will be focusing on chemical reactions of alkenes, which is the heart of next topics of organic. It's the heart of most conversions reactions. It's the answer. This part, the next part, that's 20, that session 20 will give you answers of many questions of organic chemistry. Okay, so that's what I wanted to let you know, and you have to get prepared for that. And for example of these reactions that we've taught you, you will see that we'll be covering them in near future in different parts of organic chemistry. I believe that you've been enjoying this session, and if the answer is yes, then tell me in the comment section. And if you have anything else to give us as a feedback, tell us in the comment section, and share these contents with some other students who would like to master and enjoy the beauty of advanced chemistry. So until we meet in the next session, I would like to welcome you once again and say thank you for you. But let us give God thanks for what He has been doing from the beginnings of this session to this moment. So let us pray. Our Father who is in heaven, we come before your presence. We say thank you for this opportunity. Thank you for what you have taught us in laboratory preparations of alkenes. Father, we give you all the glory and praise for everything that you've done. It's you who has been teaching, and it's you who has been simplifying this concept to your students. Father, we thank you, and keep teaching your students and remind them whenever that they need this concept. In Jesus' name, amen. So may God bless you and keep you until we meet in the next session.
Uibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania.